Hello and welcome to the Defense Tech Podcast. This week we have a special episode to conclude our DoD Critical series. I sat down with Jackie Janning-Lask and Dr. Casto, who lead the Midwest Microelectronics Consortium, or MMEC Hub. We had a lively conversation about the origins of MMEC, how to define vision for clearer mission goals, and did a deep dive into a few technologies including Secure Edge and Internet of Things. Jackie and Matt helped me better understand the criticality of collaboration to achieve common goals. Jackie Janning-Lask serves as the CEO for MMEC. She retired from the Air Force in July of 2023, bringing 35 years of DoD service to the table, including time at the U.S. Air Force and the Air Force Research Laboratory. Throughout her distinguished career, she has held numerous leadership and technical positions, most recently serving in the Senior Executive Services as the Director of Engineering and Chief Engineer of the Air Force Lifecycle Management Center. Jackie holds a bachelor's and master's degree in systems engineering from Wright State University in Dayton, Ohio, as well as her MBA from the Massachusetts Institute of Technology. Dr. Casto currently serves as the CTO for MMEC. Dr. Casto has 20 years of experience in numerous DoD technical leadership positions, including roles at the Pentagon in the Office of the Secretary of Defense and in the Office of the Assistant Secretary of the Air Force. He holds a bachelor's and master's degrees in electrical engineering from Wright State University, as well as a PhD in electrical and computer engineering from Ohio State University. Dr. Casto has authored more than 50 publications and patents and is a 2020 inductee and member of the IEEE Hardware-Oriented Security and Trust Hall of Fame. I hope you enjoyed this episode. All right, so thank you guys so much for joining on the podcast today. Can't wait to hear and learn more about you and the hub that you guys are helping to lead. So could you start by telling us a little bit about yourselves and your experiences in the defense tech industry?
Sure. I'll go first. I'm Jackie Janning-Lask, CEO for Midwest Microelectronics Consortium. I spent over 35 years with the Air Force in various engineering disciplines, ended my career as chief engineer of the director of engineering for the Air Force Lifecycle Management Center, but I really did serve in various capacities across my career before that. I was the director of the Sensors Directorate and Air Force Research Lab, spent some time at the Pentagon, responsible for the Air Force's science and technology budget. I think I spent those 35 years with the Air Force because I was so focused on doing something for the warfighter. I had a desk job most of my life, right? And really wanted to make sure that my contribution was to the mission as best that I could to make things better for the mission. And that is why I'm at where I'm at today. With MMEC. So really enjoyed my time with the Air Force, but it was time to, take on another challenge and a different mission. So Matt, over to you.
Yeah, so like Jackie spent most of my career with the Air Force, and so I'm a big advocate for getting connections, with the science and technology early, because I actually got the opportunity to start at AFRL as a co-op student, working in the Sensors Directorate, and actually, moved into a full-time position as a civil servant, and did a lot of work, bench level research early in my career, doing digital mixed signal and RF circuit design. Got the opportunity to develop some of the first device models for gallium nitride transistors. Worked a lot of small business programs, developing things like power amplifiers for, platforms like the B1, and then moved into more, portfolio and program management. Got really great opportunity to work on emerging technologies with DARPA. So help start some of their programs in heterogeneous integration, neuromorphic computing, and sensing, and kind of moving forward, almost 20 years ago in areas like advanced scaling for CMOS technology. And then got a great opportunity to go work at the command level within the Air Force Research Lab, supporting the commander and CTO for the lab as a special assistant, work in the strategy areas and really learning the needs and demand signals kind of across the broader Air Force and DoD. And then the Air Force graciously sent me back to get my PhD, and got to focus on work on trusted and assured microelectronics, specifically how to build and design secure components for communication systems and sensing applications. So worked kind of high-speed data converters. When I came back from school, helped establish the first trusted electronics branch within the Air Force. And then there we started developing emulation capability for the DoD and the first cloud-based design platforms. And that was about the time that the Trusted Foundry divestment happened with IBM and transferring over to Global Foundries. And we were in a position to really help support the MGE program. So helped establish the Trusted and Assured Microelectronics program and supporting the GPS program. I ended up being the director for the Trusted and Assured Microelectronics program for a couple of years. So great experience at the Pentagon. And then moved back to AFRL as my last role was division chief for aerospace components and subsystems, which was actually one of Jackie's early jobs, maybe the best job in the Air Force. Great opportunity to work on cross-cutting technology for airmen and guardians.
Okay, so now that we know how you both kind of got to this position, could you walk me through how the MMEC Hub was formed, how that came to be?
Yeah, that's a really good question, right? So not only due to mission, right, and the mission support, our hub, growing out of the Midwest, Ohio is a very military-friendly state, as well as we have one of the largest Air Force bases, right? Patterson Air Force Base in Dayton, Ohio, that not only has a mission with Air Force Research Lab, but also part of their mission is the acquisition of weapon systems. So when you think about everything that the state of Ohio does in support of the warfighter, and whether it's DoD, whether it's NASA, whether it's just manufacturing, we have a lot of that in the state of Ohio. So we were truly formed out of the great support from the state of Ohio. So when you look at their desire to respond to the needs of chip developers, manufacturers, the warfighter, and the public domain, Ohio was, ready to stand up and say, hey, we want to be part of this. They brought together a lot of strong leadership from across the nation to form this hub, to be focused on the warfighter, to truly bring the national security posture to the development of chips. Don't forget that 2021 during the pandemic, we couldn't get chips, right? That was our supply chain was fractured. It was really difficult you couldn't get a car. You had to order a refrigerator a year in advance. So it was something that the leadership of Ohio said, we really want to be a part of this. And in addition, bringing the leadership that we have in the team, and I'm going to focus a little bit on our team later in the podcast, but, bringing together our team, coupled with a no excuse roadmap, so no excuses, building a role-based member structure that promotes best idea governance, problem-solving prototyping, a focus on complementary workforce development, because not only are we going to focus on bringing chips back onshore, we want to make sure that we have people that are there to support any kind of manufacturing, development, the innovation. So we have to have a workforce development component as well. So the other unique thing about Ohio with our location, we have partners, and I think Matt might talk a little bit about how we're growing, but we want those partners to take what we're building and not put them on a shelf. We want to be able to have, an original equipment manufacturer, university, large corporation to take what we are doing and ferry that technology across the valley of death and transition into a system. So when you think of all those things I just mentioned, Wright-Patterson Air Force Base, technology, the support of Ohio, our focus on the warfighter, it's really, truly, our mission is to accelerate transition quickly and ensure a path of success for the warfighter and the nation.
Great. Okay. So you just mentioned your main mission of the hub. Would you be able to expand upon this a little bit and how your mission might differ from some of the other hubs?
You bet. So our mission is to achieve national security through innovation from the heartland, right?
Mm-hmm.
And coupled with our vision, which is to accelerate the recapture of global leadership in microelectronic innovation and empowering our member organizations to create and maintain and sustain a robust and resilient domestic supply chain, right? So we really want to, accelerate the recapture. So for anyone watching this podcast, it's really important to know that we selected these words very carefully when we put together the mission and the vision. We didn't just sit back and say, oh, let's throw this in there. Silicon Heartland's important. We really thought about it. We gave we called some experts in. We spent a lot of time to say, what are we doing for the nation? And, words like recapture, right? Empower, resilient, and robust to describe the supply chain. Those are not just buzzwords, but truly a clear message that we want to return the supply chain to the warfighter. So we want to recapture the global leadership that we once had in semiconductors, right? And we want to take it that next step further and onshore manufacturing, bring back the innovation, bring back a strong workforce. So that's truly part of our mission. And, as I said in my intro, where I've been spending that time for the warfighter, I couldn't think of something that, that I'm more passionate about. Yeah. And that's our mission and our vision for MMEC.
Really well said. Yeah, thank you for explaining that. So each of the hubs kind of have different technology areas within Commons that they're focused on. Some of them focus on all of them, some of them a couple. So what does your hub specifically bring to the table for the technology areas that Commons is focused on?
Yeah, this is one of my favorite questions because we were initially awarded for electronic warfare, quantum, and commercial leap ahead. But as we've grown, and I'll let Matt talk a little bit about how we've grown and added some of these other organizations like the Mid-Atlantic Semiconductor Hub, represented by University of Maryland and Booz Allen as the primary leads. They joined MMEC. We were so lucky and so fortunate to have partners like those teams, that team from the Mid-Atlantic. So they rounded out our areas with secure edge, 5G, 6G, Internet of Things, artificial intelligence. And as I mentioned several times, we work very closely with our DoD partners. And as we were working with them, we realized, infrared sensing and electro-optics are also a critical need. So we expanded our areas to 7 critical areas, not just 6, to include that acceleration of technology in the EOIR realm.
Okay, so can you expand on what that 7th technology area is past the main 6?
Yeah, the main 6. And then we added electro-optics and infrared.
Okay.
And so that was a demand signal from the warfighter that said, we use a lot of that in sensing, and we would like to accelerate the innovation and the technology for our warfighting programs.
Okay. Did you have anything you wanted to add, Matt?
Yeah, I was going to say, as Jackie alluded to, right, we really went into the right, and Jackie uses a good term, right, to be very choosy about the areas where we go into. And so as we started out, we really wanted to make sure as we expanded those technology areas that we could, support the membership, that we had, right, the infrastructure, we had the ability to build out the technology roadmap. So we had support. So that was why it was really critical as we grew the consortium. We brought on those technology areas where we aligned expertise. And so for each of those, technology areas, we have dedicated working groups. Each of those working groups has a charter. They have a steering committee champion that advocates for that working group. We have chairs and co-chairs that lead up those working groups, and they have set kind of aggressive goals for delivering on timelines that are going to help our membership to really align on common technology visions, being able to realize some of the vision for commons to be able to access and align infrastructure, make those strategic investments, broaden access models for things like intellectual property. And so not only did we add, we added the EOIR area with the, kind of the demand signal from the warfighter, as we've expanded the consortium with our southeast leadership. We're collaborating with the Southwest, but our southeast leadership with the Florida Semiconductor Institute and the Central Florida Semiconductor Innovation Engine. So that was a focused innovation engine stood up under the NSF program, which is focused on advanced packaging. So bringing that the Southeast on, we've also added an advanced packaging technology area. And so right in the middle of kind of formulating our charter and, our execution plan for that working group as well. And so each of those technologies align and, are represented by our membership model. So we've, established our membership model around 3 membership types, which are foundation, pillar, and keystone. And so again, why we formed the EOIR, we got really strong demand signal out of our keystone membership, which is our system integrators, programs, kind of the warfighting demand signal, and then aligning those to, foundation capabilities, which are things like our, semiconductor manufacturing. In the case of EOIR, right, being able to do things like, to build out materials for focal plane arrays and integration technologies, and then our pillar members, which are those really understanding the requirements and the demand signals, aligning access to the infrastructure on the foundation side, and being able to connect the dots, through innovation pipelines to deliver, products and capabilities.
Great. So we're going to touch a little bit about like foundation a little later on, but it sounds like you were very strategic, kind of like you said, Jackie, and you as well, Matt, and choosy about your technology areas and like how you're setting up the whole hub. I'm just curious how many iterations, how long did it take for you guys to get that perfect solution for your hub structure?
I don't know if it's quite perfect yet, but it's, one of the key factors in any ME Commons program is collaboration. Mm-hmm. And so we focused on having this membership and a collaborative membership, right? And when you think about it, instead of everybody just coming together, you really need to have some kind of roles and defined that says, okay, we need you here, we need you here, right? So could you imagine going into any project and not having any defined roles and responsibilities? It would just be, crazy. Yeah. And so that role-based membership has paid dividends. It's saved time, it's been efficient, it's sent a message that we want to be organized because we have to be efficient and we want to accelerate that innovation. So I don't know if it's perfect yet, but it is certainly improving. We take that very seriously in terms of working with our customers because, we're here for our members and we want them to have a good experience, be efficient, be able to provide them information that they need. And that's just one good way to do it.
Yeah. Okay. That makes sense. Thanks for sharing. So moving forward, I would love to hear a little bit about the projects that MMEC was awarded last year in the first round of project awards. It may be too much to walk through all of them here, but could you give us some highlights of what the hub is working on now?
Sure. Yeah. So like you said, we awarded projects across a number of different areas: 5G, 6G, artificial intelligence, electromagnetic warfare, secure edge. Actually, two projects in the electromagnetic warfare area. And so, these projects. We've got all have alignment to transition opportunities, aligned with program office, demand signals, warfighting capability needs. So in 5G, 6G, we're working on a wideband multifunction software-defined radio. So our lead keystone member on that is Lockheed Martin, and partnered with Intel, leveraging the most advanced onshore domestic capability for silicon technology, integrating that with advanced filter technology out of a small company, CatV, which was a startup out of the University of Dayton, and then being able to integrate that together for really dynamic, frequency agile capability for 5G, 6G that can operate in contested and congested areas, and that's using interposer technology developed by 3D Glass. So I think that's a great representation of the types of projects we have, is really bringing together the best technologies, ability, focused on leveraging and helping to build out that domestic ecosystem. So, the byproducts of all that, which are, development of intellectual property, being able to demonstrate things in relevant environments. So we're leveraging, some of the facilities and infrastructure for our projects, wherever they exist. So some of those are at the Defense Industrial Base facilities where they've established, their test facilities. We are leveraging DoD laboratory facilities to do high, TRL level type testing. One of those areas is electromagnetic warfare, where we're being able to bring in those circuits and modules into relevant test environments to show how they perform. So we're really buying down the risk to program adoption. Our other, electromagnetic warfare project is called Corsair, which is looking at configurable spatial architecture. Again, that project's being led by Lockheed Martin. So that's taking kind of the best of breed new processing technology from Intel and putting that into, kind of a dynamic configurable use environment where latency and swap, so size, weight, area, and power are really important at being able to make decisions in the battlefield really quickly in an electromagnetic spectral environment. Our project in Secure Edge, which is really exciting, being led by Northrop Grumman with partners, University of Maryland, Enhanced Semiconductor, Battelle, and NVIDIA, is being able to basically build a secure architecture around NVIDIA's commercial GPU family of products to be able to then use those, in a warfighting scenario where there are, we need to be able to protect information, where there are kind of different dynamic threat environments, being able to use commercial technology for DoD applications. So kind of the underlying theme with all these is really that alignment. You can kind of, see how we have the keystone members providing the demand signal and the warfighting need. We've got foundation members providing the technology and foundation pieces, whether that be semiconductor, fabrication or components, and then our, pillar members being able to connect the dots to deliver the end products.
Okay. So one thing we haven't touched on very much in the podcast is the technical area of Secure Edge / Internet of Things, which you just mentioned was the last project that you described. Could we kind of take it back, and could you explain to us what this technology area is and what type of technologies it could entail?
Yeah, so Secure Edge, Internet of Things. So as I mentioned with our project, which is, we kind of acronym is GUARD, but it's a validated GPU-based secure processing module. And so we really want to be able to, quickly take things from the lab, and take things that are maybe, developed and designed for even commercial applications, and being able to accelerate those to the mission. So being able to bring those to the fab with, being threat aware. So whether that's there's a very dynamic landscape for, hardware and software vulnerabilities, the ability to protect critical information during processing, as well as overall supply chain concerns. So, the proliferation of counterfeit technologies, the DoD typically field systems for long periods of time. And so we want to be able to quickly, right, modernize, upgrade capabilities as that landscape changes, as we, learn about new concerns, working in a very global supply chain. And then, right, trying to address and mitigate some of those risks where we can by, having things like provenance and traceability that become better in a domestic semiconductor environment, as well as, right, being able to retain and protect the intellectual property in an ecosystem where it can be reused in a secure environment by a broader range of, especially within Commons, right? We're being able to develop that consortium type IP that can be leveraged across membership and then broadly, right, across other hubs across the national network.
So is that Internet of Things aspect, protecting the intellectual property of the technologies being created?
Yeah, so Internet of Things provides, very, very commercially driven. So you've got lots of, right, distributed sensing, whether that's imaging technology or, right, communications technology where you're developing, even say a mesh grid of communications. So there's lots of innovation going on in the IoT space, whether that's, in your home, on your, smart devices, or, in a, being able to deploy, kind of a low cost communication network or, wireless, kind of Wi-Fi or Bluetooth. And so one of the questions right around Internet of Things is how do we use that technology for DoD applications, knowing and also being able to integrate those types of technologies into an architecture that can support, needs for national security.
Okay, that makes sense. So considering all of the technologies we kind of just covered, how will these technologies, all of them under Commons, help to re-onshore microelectronics manufacturing capabilities in the U.S.?
That's a great question. Matt just described secure or Internet of Things, right? And the security and the national security that we use in our mission statement, national security through the heartland, right? So it doesn't matter if it's a military mission or if it's your Ring doorbell, right? You want security. You want to ensure that is there. So, our mission, as part of onshoring manufacturing capabilities, the more we can accelerate this innovation of technology along with the entire semiconductor ecosystem, the chip design flow, the design, the characterization, each step in that process, we can begin to own that supply chain once again. So I go back to when we, during the pandemic, when we didn't have what we wanted, right? We couldn't get what we needed. We want to own that supply chain once again. We want to build it so we can control cost, right? Reduce risk and manage the inventory and supplier relationships, work with the ecosystem to build a very strong foundation and promote that national security. So the MMEC Commons initiative is just, the CHIPS Act, MMEC Commons, and then especially MMEC, right? Our goal is to bring that back to the US.
Yeah, really crucial effort. I'm sure it feels very gratifying to be a part of it. So as I understand, during the first year of Commons, the hubs were focused on building out hub operations and infrastructure. And you touched on this a bit in the beginning, but could you share what that's been like, and what foundational items you guys have been focusing on with building out your hub?
Yeah, I'll start out with this because I will tell you this is was my favorite part in standing up the hub was providing that infrastructure, and here's why. As you know, that providing capability is part of our mission, and then the workforce development is part of our mission. And so what we chose to do is we provided capability, in our case, for MMEC, to 2 universities who are very steeped in providing that technical education, right, and then the training, but also can develop and provide the teaching, the processes and methods in order to build future chip development. So we purchased a multi-wafer deposition tool for Penn State University for 2D materials. And then at Ohio State, we also had some epitaxial growth as well as material and design characterization tools at the Ohio State University, right? So knowing that these tools are not only in support of our projects, but they're going to be impacting students, it kind of gives you this vision. It opens up the aperture to say, you know what, we're providing that foundation for the growth of the workforce in our project. So I'll let Matt talk a little bit more about the infrastructure, but it really was exciting to say, we're part of that and we're going to make a difference.
Yeah, no, and yeah, Jackie said we've had the best partnerships you can imagine, right, with our university ecosystem. So really great support from Dr. Steve Ringel at the Ohio State University, and Joan Regwig at Penn State University. So at OSU, we're really, and also at Penn State, we're really building on kind of that existing user facility structure that provides, right, that broader access, which is part of the the Commons vision of really lowering the barriers to access to infrastructure. So at Ohio State, we've established the Microelectronics Innovation and Technology Cluster called MITech, which leverages their Nanotech West facility, the SEAL Lab, CMAS, which is really a world-class facility for microscopy and analysis. And so with those infrastructure investments, we've, in order to then lower the some of the barriers to transition those into a domestic capability, we've scaled up wafer sizes that can help to lower cost and accelerate innovation. So installing MOCVD capability as well as new MBE capability. So those are different ways of depositing and growing materials. And also I'll throw in a little plug for one of our other projects we didn't mention earlier, but the MBE capability that we're installing at OSU, working with Dr. Sanjay Krishna, is building materials for focal plane arrays, which is supporting our Centroid project, which is building a large format focal plane array that can be used for being able to see in the IR spectrum. So being able to see in other than visible type parts of the spectrum, to be able to provide that capability on shipboard applications, and being able to leverage advanced integration for the back-end processing and things called ROIC. So really excited about Centroid, and that's a great example of a Commons project that's leveraging infrastructure that we've made an investment in, that's now also available to the broader membership. We're also building out a advanced characterization lab within the Nanotech West facility at Ohio State, and we're going through a really deliberate approach to scaling up that capability. So bringing in additional parts of the spectrum, so being able to go to higher frequencies to be able to build device models and process design kits. So we're installing a tool from Mori Microwave, which basically allows us to build models that can cover spectrum bands that support electromagnetic warfare or 5G, 6G, and then those high kind of high voltage power electronics areas in the commercial leap ahead area. So both in gallium nitride and gallium oxide, which are technologies where we have a strong expertise onshore and really an opportunity to scale up the access models on the foundry side. And then and our approach there is to really make that remotely accessible. So kind of integrating that into our broader digital infrastructure, which not only includes access through a platform we call Connect, which is aggregating capabilities across our membership, looking at capability and capacity, and where there would be availability of equipment to be able to connect prototyping and ramp lines, and then building that also in as we develop models, being able to make those accessible in our design platform. So we've established a platform called Design, which is lowering the barriers to not only the equipment, but also the electronic design automation tools, which can help to actually design chips send them right in the right types of formats out to the foundries to be able to be fabricated. And so all these different pieces of infrastructure are really working together to integrate and both lower barriers and accelerate the pipeline.
Great. Thanks for explaining. So I'm kind of nearing the end of my questions for you, but I would like to take a minute for you guys to tell me about your hub's new accelerator initiative. Could you break that down for us?
Go ahead, Matt.
Yeah. So we talked about that. One of the opportunities we have, right, with that infrastructure as it's being deployed, becoming available, right, building out the business models for access to that, and ultimately make those sustainable. We have a really unique capability to support our membership and right the broader industry through both an incubator and accelerator capability. So we have we just had our annual member meeting, and we made an announcement that we have a partnership with Falcon Eye Ventures, which is aligning things like an angel investor network with private capital, more access to non-dilutive resources to support members, because typically, especially in the hardware area, access to capital to continue development is one of the most significant barriers. Right, it's a lot of times it's a very risky venture, right? It's a lot of times easier to invest in a software startup where there's lower capital investments. The timelines are much quicker. So by bringing the infrastructure that we're putting in place under the Commons program, right, tying that to the investment capabilities, venture arm investment, and then being able to leverage that infrastructure, all the costs associated with that is kind of taking the risk off of those investors, and then applying those to relevant DoD problems, which right we get the demand signal from our membership model and from our Keystone members and market sector, so we can connect the dots really quickly, accelerate the pipeline, provide access to all the tools and resources, right? Connect those with the resources and move things through really quickly. So the access to government funding and DoD problem sets is part of that, really a part of that critical non-dilutive capital investment, connecting that with some of the private sector. So we're really excited about that incubator and accelerator model because it's so fundamental to being able to leverage all the investments that are being made to have the largest impact.
Cool. Yeah, that's very exciting. Speaking of crucial aspects, I saved the best question for last. Your hub has implemented some other initiatives as well that are focused on workforce development, which we talked a little bit about. So speaking of workforce development, how is your hub helping to build a pipeline of qualified microelectronics workers, and why is that so important?
Yeah, so through our workforce development strategy, as we build it, we started with the end in mind. So what do we want to achieve, right? So if I want to have a lab tech, or if I want to have a PhD student do some, innovative work, if I need someone to operate the clean room, right? Or we looked at each one of those skills that we need, and we backed it all the way up until, a kid was 4 years old. And we said, okay, how do we start, right? K through 12. And we broke that down. And then we looked at community colleges and universities, veterans, professional associations, organizations such as Girl Scouts, Boy Scouts, right? How can we impact STEM schools? How can we find people who want to upskill or reskill? And so you look, you open up the aperture and you look at all those people who would be interested, and then now you got to capture them, right? You got to start that drive, and that drive starts around 4th, 5th, 6th grade, right? So you need to start attracting them there, but you also, at the same time, you can't wait until the 4th, 5th, and 6th graders graduate, right? because we've got some fab facilities that are coming on board in 2026, 2027. So I need somebody now. And so you start to influence the younger generation, or you reskill. And so I think the best part of the workforce development strategy is how our partners are coming together with workforce strategy, the gap analyses that have already been done, sharing some of the training that they have. What can we leverage? What can we accelerate? How can we drive change? How can we influence that STEM workforce, right? And so that's a big part of what we're doing right now. So it includes, mentorships, internships, shadowing. I have made it this year on the performance objectives of each one of my folks. You guys got to take this seriously and go to a school. I want you to go to your kid's school if you want, but I want you to talk about MMEC, and I want you to talk about the future of microelectronics. I think kids can understand this, right? They use their phones. Break open a phone. I'll give you one of my old ones. Break it open, and show it to the kids and say, hey, you wouldn't have this without this type of technology, and we need to make sure that we have people that can do this in the future. So we're very excited about building that pipeline and using every possible resource that we can.
Yeah, that's really cool, really powerful. I like how you're starting so early, getting in kids' heads, like how important this is, because it really is. So that's about all the questions that I have, but I just wanted to give you a moment if there's anything else that you would like to highlight about your hub that we haven't touched on.
Okay, so I mentioned this earlier, I said that I would talk about it later. It's our people, it's our team. We have, bringing together a team in a very short time period that we had. So we started in October of 2023. And if you recall, and, projects were due in February of 2024. So we didn't have much time to, gather requirements and put together ideas and projects. And, but fortunately with the people that we have on our team, they have that sense of mission and purpose. And we've often said to each other, this is the best team in the world, because everybody contributes. It doesn't matter if you're working workforce development or project management, you're the CTO, you're the CEO, you're head of finance or head of contracting. Everybody knows their role, and everybody is so engaged in trying to make a difference for the nation. And so I just got to give a shout out to our MMEC team, because they're an amazing group of people. And couldn't be more than blessed to be, with them on this journey. They're amazing. So Matt, I don't know if you have anything to add. And
I would just say, to echo on top of Jackie, we, certainly, Jackie's been really able to kind of assemble the best team. And what I mean by that too is also you see it kind of represented in the types of things that the team pursues, and I think that's also reflective of the type of team that, we're working with within the Commons program and the government, and also with STXL, some very kind of definitive exemplars of that are some like the cross hub enablement solution, where 6 of the hubs have come together, to jointly, work together. So we had folks on our team that, have reached across to different hubs to work together on requirements and establish, and that's all because we have a team that, is really focused on the mission. So whatever it takes to, reach those goals, to make sure that we are, that whole lab to fab to mission is to really delivering, mission capabilities. We've also been building on top of that collaboration for, things like collaboration with California Dreams and the SWAP Hub on Moses 2.0. So, they're bringing their aspects of development. We're partnering with our parts of our expertise that we have and part of our infrastructure to bring a capability that is more for the nation by, working together. And that really happens because of the team, because of the collaborative nature, and really the selfless, putting the mission kind of service before self type of initiative that, we've been able to bring forward from some of those, say some of those historical roots and working on supporting the warfighter. So I think that's, you see it in the day-to-day activities going on within MMEC because we have a team that's focused on those things.
Yeah, I love that. Sounds like you're really embodying that core value of collaboration. Just great to hear. So that's about all we have. How could someone get connected with MMEC if they're interested in becoming a member or partnering, getting involved?
So we have a very active and engaging hub. We have quarterly meetings. We have new member meetings, orientation meetings. You can find out information at mmeconsortium.org. And that is our website. It'll give you the information that you need in terms of the consortium, the leadership, about us, how to contact us, what some of the opportunities are. We, like Matt said, it's not just accelerating lab to fab, but it's lab to fab to mission and market. So we're looking at the mission, we're looking at commercial innovation, and sharing those opportunities with our hub members is one of the other reasons that we're here.
Okay, wonderful. Well, I want to thank you both for coming on and walking us through all that. Very exciting time for you guys, and can't wait to see where your hub's going to be in a year from now, 3 years from now, all that. So thanks again for coming on.
Thank you, Sydney. Appreciate it.